Alright, this is section 9.1 in your textbook on greatest common factor and factoring by grouping. You should be familiar with factoring, and maybe it's been a while, but this is mostly review and refresh. I will teach it from the beginning, but not quite as many examples, a little bit quicker than I would if you had never seen it before. So if you're not familiar with factoring, you might want to watch the videos in the textbook or go to tutoring and really brush up on your skills. Factoring is one of the most important skills you can have in algebra, especially when you get into college algebra. You'll just be expected to factor just as quickly as you solve. So factoring is a very important skill to master and make sure you fully understand. So I put the entire section on one page. If this is not enough room, of course, you've got extra paper handy so that you can have more space if you need. Also have your calculator handy if you're not so good with your multiples. It's good to have your calculator nearby so that you can use it to let you kind of help you get multiples of different numbers as you need them. So the first thing to review is a GCF. So anytime you see GCF, it stands for greatest common factor. And then we'll use GCFs to do factoring by grouping. So it says, what is the GCF for the following sets of terms? So if I have 4 and 24, I'm going to write on my scratch paper here. What we're going to do is think of all the pairs of numbers that multiply to 4, like 1 and 4, or 2 and 2. We're also going to think of all the pairs of numbers that multiply to 24. Every number is called a factor of 4. So for 24, we've got 1 and 24, 2 and 12, we've got 3 and 8, we've got 6 and 4. Let's see if there's any more. I think that covers all the pairs. So you want to think of all the possible pairs of values that multiply to 24, and each individual number is called a factor. Then we're going to look for the greatest common factor. So all numbers have a 1 as a common factor. Everybody can divide by 1. These also have a factor of 2 in common. They can both divide by 2. And the biggest one that they share would be 4. So 4 is your greatest common factor. So there could be a whole bunch of common factors. We're looking for the biggest one, the greatest common factor. It's very important to not only find a common factor, but to find the greatest common factor. So the GCF between 4 and 24 would be 4. The GCF between 15 and 20 would be 5. There's an X on this term. There is not an X on the second term. So 5 would be your GCF. On the next pair, we've got 15 and 25. So they have a common factor of 5. We have x squared, which is x times x, and then we've got a single x. So they each have an x in common, and so x is part of the GCF. So the 5 comes from the coefficients, and the x comes from the variables. So sometimes your GCF has values and variables. And this last one, same idea. Between 9 and 27, they have 3 in common, but they also both have 9 in common. So 9 would be your GCF. Between x squared and a single x, they both have 1 x in common. And between a single y and y squared, they have a y in common. So 9xy would be your GCF. I believe I posted an entire page of practice on this, just finding those GCFs. You want to be very, very diligent and very good at finding GCFs throughout Chapter 9 and also Chapter 10. So you'll see this again and again. After that, once you're really good just finding GCFs, now we're going to factor out the GCF from the polynomial and rewrite the expression in what we call factored form. So this just takes some practice, and again I have a whole page of these to practice online if you want extra practice. So let's look at 16 and 12 and think about what they have in common. I believe 4 would be their GCF. and then this one has an x, and this one does not have an x. So that's the only value they have in common. Once you find your GCF, you're going to open a parentheses, and you're going to divide each value by the GCF. So 16 divided by 4 would be 4. The x would still be there, and then minus 12 divided by 4 would be 3. So that would be your GCF. And this is what I call the leftovers. And that's not the official math term, but that's what I call them, leftovers. If you were to multiply back the 4, if I were to do 4 times 4x, I would get 16x. If I were to do 4 times negative 3, I'd get the minus 12. So the expression you write needs to be equivalent to the expression you were given. If multiplying it back in makes that expression, you have done it correctly. Another thing to look for is that there's no more GCFs left in the leftovers. The leftovers should have no GCFs. So you just want to double check that when you're working through. Let's look at the next one, 28x plus 7. So between 28 and 7, there's a 7 in common. There's an x on this term, there's not an x on that term, so that's the only thing they have in common. 28 divided by 7 is 4. The x will still be there. 7 divided by 7 is 1, so we'll put plus 1. If you start with 2 terms in the expression, your leftovers should have 2 terms. So you don't want to lose any terms in this procedure. And again, if you were to multiply that back in, you'd be back with what you started with. So this is what I call the GCF, and these are what we call the leftovers. And you'll see why I'm calling them leftovers once we get to factoring by grouping. So I just put a whole ton of these on here, and you can just keep practicing. You can do it on your own and pause the video, or you can just continue to follow along with me. Here we have 8 and 4, so there'd be a 4 as a GCF. There's x squared and x, so I can take out an x. And I'm left with 2x plus 1. Here we have a 5 and a 2, so there's nothing in common other than 1. Then we have a y and a z squared. Well, they're not the same variables, so we don't have any variables in common either. So we could take out the 1, and we'd be left with 5y minus 2z squared. Because it's a 1, we don't normally write it if it's just a coefficient, and so we'd really just write the same expression, 5y minus 2z squared. And it's not that it doesn't have a GCF, it's just the only GCF is 1, so it doesn't change the expression. We do the same thing with 3 terms. So if I have 18, 9, and 6, I need to find what's common between all 3 of them, which would be 3. And then I have x squared, and x cubed, so I can take out an x. And that would leave me with 6 plus 3x minus 2x squared. So I'm dividing, and I'm also taking down one of the powers. So I took that x out, took one of those x's out, and took one of those x's out. So the powers go down based on what variable you take out. And again, if I were to multiply it all back together, I should be back to that original expression. Again, we've got 6, 3, and 12. So that's a 3 in common. We've got x squared, x to the 3rd, and x to the 4th. So I can take out x squared. That's going to leave me with 2 minus x plus 4x squared. So if I took 2 x's out from 4, I had 2 left. I took 2 x's out from 3, I had 1 left. I took 2 x's out from 2, I had no x's left. So just some students struggle with those exponents. So just make sure you can follow those. And these last two are a little more complicated here. We've got 3, 2, and 5. They don't have anything in common other than 1. We've got x to the 3rd, x squared, and x. So I can take out an x. We have y, y, and y, so I can take out a y. It's going to leave me with negative 3x squared plus 2x minus 5. Another way to do that is to take out what we call the leading coefficient. So the first coefficient that you see. If the leading coefficient is negative, a lot of the times we take the negative out. So we would take out a negative xy, and it would change the sign on those three terms. So this would become positive 3x squared, negative 2x, and positive 5. Either answer is correct, but for factoring by grouping, it helps to take out any leading coefficients that are negative. So if the leading coefficient is negative, go ahead and take it out. So same idea with this last one. We have 9, 5, and 7. They don't have any values in common other than 1. We have x to the 4th, x squared, and x, so I can take an x out. We have y squared, and y squared, so I can take out y squared. That will leave me with negative 9 x to the 3rd plus 5x plus 7. And because that leading coefficient is negative, I can take out negative xy squared. That leaves me with positive 9x to the 3rd plus minus 5x. All the signs change. And then minus 7. So for what we're going to be using factoring for, if you have a leading negative, it's good to take it out. All right. So that's GCF. You want to get really, really good at GCF. And once you have that down, we're going to use GCF several different ways. And one of the first ways we use it is for factoring by grouping. So factoring by grouping has 3 simple steps. The first step is to factor out the GCF from the first 2 terms. And then you factor out the GCF from the second 2 terms, and then you reorganize into back-to-back binomials. So factoring by grouping is used for 4-term polynomials, or 4-term expressions. So you'll see the examples on the second half of your page all have 4 terms, and so we're going to use factoring by grouping. Hopefully you've seen this technique before. I'll go over it a little slower at first. And then once you catch on to it, pause the video and try some on your own, and then play it back to see how you did. So we're going to look at just the first 2 terms and take out what's common from just those. So I have x to the 3rd and x squared, so I can take out x squared. That leaves me with x plus 5. And then I'm going to do the same thing for the second 2 terms. Whatever sign is in the middle is the sign you keep in the middle. So if that's positive, you leave it positive. If that's negative, you make it negative. So whatever sign is in the middle here, we put that same sign in the middle here. Then between 3 and 15, there is a 3 in common. That has an x and that does not. So that leaves us with x plus 5. Now if you did this correctly, your leftovers should match. So notice I had x plus 5 left over from the first 2, and I have x plus 5 left over from the second 2. If you did this correctly, those should match. So what we're going to do is reorganize, and colors help here if you don't remember how to do this or if you've never seen it before. We're going to put the x squared and the plus 3 together to form a binomial. X squared plus 3. And then we're going to put our 2 leftovers together and write them as one binomial next, x plus 5. Your textbook teaches that slightly differently, and it will put x plus 5 first and then x squared plus 3, but that doesn't matter because you're multiplying. As long as your final answer has x squared plus 3 and x plus 5, it doesn't matter which order you write them in. So I call these back-to-back binomials because of the back-to-back parentheses in the middle. That is how you know you're in factored form. And if I were to multiply these back together using the FOIL technique, I would get back to my 4-term expression. So it's very important, if you're not too confident with yourself, multiply these back together and make sure you get the original expression. So same idea, let's try it again. We have a to the third plus 2a squared. So I'm going to take out an a squared. That's going to leave me a plus 2. And then I have positive 5a plus 10. I'm going to bring that plus sign down. Between 5 and 10 I can take out a 5. And that also leaves me with a plus 2. So if I did this correctly, I should get a plus 2 as both leftovers. Then I'm going to rewrite it. I'm going to take the GCF from the first two, the GCF from the second two, and put them together, and then write my leftovers. And if you need to color code that again, that's totally fine. Take your two GCFs and you put them together to make your first binomial, or second, depending on how you look at it. You take your two leftovers that should match and you just write them once together. And the binomial order does not matter. So if you want to, you can pause the video and try the next set and then play it back, or you can just continue to follow me. So let's see, we have x to the third minus x squared. So they have an x squared in common. That leaves me x minus 1. And then I'm going to take this minus and bring it down. Between 2 and 2 I can take out a 2. Because I took out a subtraction, that addition is going to change to subtraction. So if you take out a negative, it changes the sign of the second piece. So then my leftovers match, and so I'm going to write it x squared minus 2 times x minus 1. And that is again what we call factored form. Let's try it again with another negative in the middle. So here I can take out x squared, leaves me x minus 2. Here I'm going to take that negative out, and then 3 is the GCF, and that's going to leave me x minus 2. So again, that sign changes as well. If you take out a negative, it changes the sign of the second expression. So factored form would be x squared minus 3 times x minus 2. And if you were to multiply those back together using the FOIL technique, hopefully you're familiar with that, you can double check and make sure you get back to your original expression. Just have a few more to practice here. Sometimes it's a little tricky when there's multiple variables involved, but the procedure is the same. So I'm going to look at 6xy and 10x. Between 6 and 10 there's a 2 in common. They both have x, and that's going to leave me with 3y plus 5. And then here, between 9y and 15, they have a positive 3 in common. Again, I'm going to use that same sign. That's also going to leave me 3y plus 5. So they can look a little more complex, but the procedure is the same. Make sure your leftovers match. That gives me 2x plus 3 times 3y plus 5. And if you were to multiply those back together, you would get your original expression. Try it again with x's and y's. Looking at the first two terms, I'm going to take out a 5x. It's going to leave me 3y plus 4. Looking at the second two terms, I'm going to take out a positive 2. It's also going to leave 3y plus 4 for a final answer of 5x plus 2 times 3y plus 4. Those are your back-to-back binomials. That's called factored form. Alright, we got a few more. Just keep on practicing. Looking here, I can take out a y squared. That leaves x squared plus 3. Here I can take out a negative 5. That's going to leave x squared plus 3. So I took out a negative, it changes the sign. For a final answer of y squared minus 5 times x squared plus 3. Again, I'm going to look at the first two terms. Take out an x, that leaves y plus 2. Here's a little trickier. I'm going to take out a negative 1, and I need to write the 1. It's very important because I need that second piece for the binomial, and that leaves y plus 2. So if you don't have anything in common on that second part, take out a 1 because you need that as what we call a placeholder so that your leftovers are correct. So we have x minus 1, that makes up the binomial, and then y plus 2. And the last two here, we're going to look here, take out a 2, that leaves me y minus 6. Here I'm going to take out a negative x, and that's also going to leave y minus 6. So because I took out the negative, it changed the sign for a final answer of 2 minus x times y minus 6. And finally, here I'm going to take out an x. That leaves y plus 9. Here I'm going to take out a negative 7. And that should also leave, what happened here? I think this should be a y. That's a typo. That should be a y. So that should be y plus 9 again. Your leftover should always match. That was just me mistyping. I apologize for that. So then we have x minus 7 times y plus 9. So you want to get really, really good at factoring by grouping. We're going to see it again in the next section. And there's a whole page of practice just so you can really master this skill.